I want to look at this vector is orthogonal to P, right? So what is this vector? Or this vector, it doesn't matter which direction you pick, right? Both
X minus u.
u, right? So x minus u is orthogonal to P. You look at all x such that x minus u is orthogonal to P. That will describe all the points on this hyperplane, right? That's all. So what is this? This is x minus u transpose P equal to 0, right? Euclidean geometry and inner product is basically A transpose B. Then this is what you get. So what is the if you rewrite this, what do you get? X transpose P minus U transpose P equal to 0, right? Or I can write this as P transpose X equal to U transpose P. Well, U transpose P, I'll rename it. I'll call it as B. So it's B, right? In general, how do you write a hyperplane? It's A transpose X plus B equal to 0, or A transpose X equal to B, right? That's how you write your hyperplane. So let's write that as a definition, okay? A hyperplane is described by the following set. What is that? I'll just say hyperplane, which is all those points in Rn such that A transpose X equal to B. Okay, this is the hyperplane. Maybe I'll write A comma B here to describe the hyperplane, the parameters, right? A and B. Is that fine, everyone? Right, this is the hyperplane. Okay, fine. So suppose I give you 2 points. How do you say that I can squeeze in a hyperplane between the two, right? In other words, if I have a hyperplane, let's say this is your hyperplane, right? I should be able to say, I should be able to describe all the points above the hyperplane, right? So how do you do that? Huh? How do you do that? How do you do that? How do you describe all the points? So suppose I give you a line, right? How do you describe all the points above the line? How do you do that? Hmm? Hmm? How do you do that? Hmm? How do you write all the points above the hyperplane and all the points below the hyperplane? I know how to write all the points at the plane, on the plane, right? That is given by this, easy. But above and below, right? Less than and greater than, right? So let me write this as A comma B plus, which is set of all x belonging to Rn such that A transpose x is less than or equal to B, or maybe I'll say greater than or equal to B because it's plus, and I'll write A comma B minus as set of all points in Rn such that A transpose x is less than or equal to B, right? This is how I can describe. Now, going back to the previous question of this, right? Whether are the data points separable by a hyperplane? How do you write that? So let's formalize this whole thing. So what is the data set now? So data set will have, let's say D1. This is the first data set, which is x1 1, y1 1, x2 2, y, okay, x1 2, y1 2, and so on, x1 n, y1 n, right? This is one set of data points. Maybe I'll okay, so okay, so I don't think I need to write y1 y2 here. Okay, I'm sorry about this. So I need not label it, right? So the first data set corresponds to, let's say, spam. Then I don't need to write this, right? I'll just say x1 x, how do I, okay, x2 xn. Okay, this is the first set of data points. What is the second set of data points? maybe I'll use Z. Okay, Z1, Z2, etc. Zn. So this is the second set of data points. I want to ensure that both are separable by hyperplane. What do you mean by that? So if D1 and D2 are separable by a hyperplane, then it means what? I should be able to have a hyperplane in which you look at all the points above it, right? That should contain D1, right? And all the points below it should contain D2, right? Then there exists AB such that H AB plus. So D1 should be here and AB minus should contain D2, right? That's it. D2 should be in the lower half, D1 should be in the upper half, and vice versa, whatever, depending on your naming convention, right? So that's what you mean by separable, right? Okay, well, of course, strictly speaking, there's some technicalities. Basically, what if it's on the hyperplane itself? We'll push it to one of them. Okay, so maybe I'll make that very precise here. Maybe I'll say strictly less than here. Okay, that means equal to is the hyperplane, right? HAB is the hyperplane. Less than B is minus, and greater than R. Okay, I think, I think both should be greater and less than, right? Equal to is all the points on the hyperplane. All the points above it should be greater than, strictly greater than. All the points below should be strictly less than, right? Okay. Now, of course, using this, the obvious question is whether there exists such an A and B, right? How do you find such A and B? Okay, that's a question that one can pose, right? You can say that whether I can pose this as an optimization problem. If so, what is the optimization problem, and how do you come up with such an optimization problem? So now, can you guess what should be the optimization problem? Wild guess, that's also fine. What should I do? What should I do? See, let's look at the constraint first. Okay, so what are the constraint we need? So problem, right? So let's look at constraint. What are the constraint that we should put? Suppose I give you A and B, right? And I say that it separates. So what should be the constraint? Huh? What should be the constraint? See, what can you say about A transpose X1? Should be less than or equal to B? True? Right? A transpose X2 should also be less than, okay, I'm sorry, it should be strictly less than B, right? Because it belongs to lower or upper. It doesn't matter, okay? So this can belong to, I said D1 is contained in plus, right? So that means plus means what? My convention? Greater than. So I should change this. Okay, so it should be greater than. It's above the hyperplane, right? X1, X2 all belong to above the hyperplane. What else? This is one set of constraint, right? What is the other set of constraints? A transpose Z1, right? Z1 is less than B. A transpose Z2 is less than B, and so on. A transpose Xn, sorry, Zn is less than B, right? Now these are constraints, but what is it that what is the problem? So the problem is I have to find A and B, right? But this is just a constraint, right? These are called constraint set. I'll call it as constraint set. Okay. But this is fine. But what is the problem that you will solve? Typically optimization should be maximization of some function subject to some set of constraints, right?